All right, and where is everybody, by the way? We are now recording, and oh, Melissa, you're here. I guess that's weird because normally in my other class I have to admit people, and I don't know why. I have a feeling. Let me ask you. No, it says guest. So Caitlin Johnson, did you download the Teams app?
Yes. Can you hear me?
Okay, I can hear you. And how did you log into Teams? I'm just curious. Did you use your UVU ID or something else?
I used my UVU ID.
And it worked.
Yeah, but I had it for a job on campus, so that might be, I don't know.
Oh, really?
Yeah.
Does UVU use Teams?
Yeah, they do.
Oh, wow. I didn't know that. Because I noticed everybody else is a guest. So I'm assuming that most of you, the others, are watching this. Oh, Corinne, are you, well, it says guest. Corinne, did you download the app?
Yeah, I already had it for a lab I'm a part of.
Okay. So do you used your UVU ID?
I actually just used my personal ID for the app, so I don't know.
Oh, okay. So I have a feeling. So here's the deal. So Carter, let me ask you this question. Carter, you're using the web app, is that correct?
Yeah.
Okay. Did that ask you to log in?
No, I think because I was already logged in to my UVU thing when I clicked your link, that it just let me come right in.
Well, I think if you use the web app, it actually doesn't ask you to log in.
Yeah.
So, so the problem is with these recordings. Number one, my screen, and I don't care that I'm small, but you guys will care when I start presenting material. And I'm going to try to share my screen to make it big, and I think that will help a lot. But number two, yesterday in my college algebra classes, I sent a link to the recording, and nobody could see the recording. So probably what I'm going to do is I'm probably going to post these on YouTube, these videos, and then it doesn't require, I mean, you just use your YouTube login. I guess you can watch them even without logging into YouTube, but so that's probably where I'll be posting the videos from here on. Now, Tori asked a question about whether we're going to have one test or two, and I haven't decided yet, is the short answer. The longer answer is I haven't decided how we're going to do tests. The math department is encouraging us to use something called Proctorio, which I've never used before. I think I actually had a dream about it last night. The testing center might have Proctorio, but I believe, Caitlin, did you used to work in the testing center or somewhere else?
I used to work in the library, so no.
In the library. So the testing center. Once in a while I get a testing center employee. Is the testing center closed? I think it is, isn't it?
Yes.
Yeah, it's closed.
Yeah. So
I did a practice exam on Proctorio for another class that I have, and I like it because it doesn't it doesn't end your test if it looks like you're cheating. It'll just flag parts so that you can watch it again, because I mean, you never know what's going to come in your background, but I liked the technology.
Okay, so basically, as I understand it, I've never used it, so I don't know, but basically you're going to need a webcam, and it basically watches you and monitors you for cheating, I guess. I don't know. And so I think I'm going to have to use that, and so I don't know how it works. I've gotten a video, and I watched one of the videos, and it didn't explain near enough. So at any rate, that's probably what we'll do. I mean, the problem is this last test is going to be, especially if we don't split it up, it's going to be a lot of information, and it's going to be very difficult, even in a live environment. And now we're doing it from home, and so that's not helping. So this material is very difficult. part of me wants to split it up into two, so it's not, so each test isn't as hard, but we'll see. I don't know. So, so we'll probably be doing Proctorio. So anyway, all right. So what I'd like to do, we're kind of starting chapter 17, but I actually have my own lecture. I think I might quiz you guys on that. So I'm going to share my screen here. The problem is I don't know which screen I want to share. Share. How do I share? Okay. So let me just do this first example. So chapter 17 talks about the language of hypothesis testing. So the example I want to give to you, and I probably will share some of these notes. So I think it is helpful if you guys want to write this down, because just the act of writing it down will help you remember it better. But let's say that you and a friend are having you're betting on a coin flip. So heads you win, tails your friend wins. So the coin comes up, tail, 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 tail. So the question is your friend cheating? What would be the probability of 5 tails in a row? So up to now we've said, let's talk about our alpha. Okay. What is the typical alpha that we use when we're doing something like this? Do you guys remember?
Is it 0.5?
Not 0.5. At 0.05. Is that what you meant, Carter?
Sure, whatever.
Okay. So the question is your friend cheating? And so the other question is, what is the probability of getting 5 tails in a row? So let's talk about the probability of getting 1 tail. What would be the probability of 1 tail?
50%.
50% or 1/2, right? Okay. What would be the probability of getting a second tail?
50%.
Also 50%. So I'm going to multiply those together. 1/2 times 1/2. And so if I repeat this 5 times, it's just going to be 1/2 5 times, right? 1/2 times 1/2, which works out to be 1 over 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1 divided by 32, and I can't remember what that equals. Here, let's do my quick calculator here. 1 divided by 32, so that would happen about 3% of the time, okay? So 0.03125, okay? So the probability that happens is 3% of the time. So would we call that an unusual event?
Yes.
Yes, it would be unusual because it happens how often? Well, we just calculated it would happen about 3%. So if you played this game 100 times, you flipped a coin 5 times, and then you did that 100 times, about 3 out of 100 times you would get 5 tails in a row, okay? So we would call that unusual, but not impossible, right? So the question is, would you feel, well, let me ask you guys, would you feel comfortable, and we're going to pick on Vicky and Tori, or Rachel and Tori, because they're sisters. So you sisters, would you feel comfortable accusing your sister of cheating if it only happened 3% of the time?
Yeah.
Yeah. Because Tori always cheats, right?
Always.
All the time.
All right. So, but Tori, you would say, wait a minute, I wasn't cheating, right? Because you know, that's just a happen chance. And so the idea behind the alpha is it's kind of a decision rule. We're going to say, okay, we're going to say, if it was you and me, if you thought I was cheating, well, if it happens less than 5% of the time, I'm going to call you a cheater. Now you could change your alpha to be, so your most common alphas are 5%, 0.05. You'll also see 0.01, and you'll also see 0.10, okay? Now, typically when people are doing these, you'll use 0.10 if it's a really small sample size, and we've only got a sample size of 5, right? So this isn't very large, okay? Typically, if I don't give you an alpha, assume the alpha is 0.05. If you want to be really sure, okay, if we were scared, if we didn't want to falsely accuse someone, we might say, well, I want to be right 99% of the time. So if I had an alpha of 0.01, 0.03 would not be enough evidence of accusing someone else of cheating, right? And so you might, if you wanted to be super sure, a lot of times they will use an alpha of 0.01. I will tell you that on genetic tests, they use an alpha. I was really surprised. I used to work at the College of Dermatology at the University of Utah, and theirs is 1 times 10 to the -6 power, -16 power. Here before I do that, I'm trying to make that an exponent here. And so another way to rewrite that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now that's quite an alpha, huh? But he's trying to get in the room and I have to let him in. Just 1 second here. Oh, it's Faith. So you can use whatever alpha you want. The fact of the matter is, with genetics, because we have so many genes, if they used 0.05, they would probably end up with a few thousand genes. And so they use this alpha, which is just crazy. But they will still, like if you're trying to find a specific gene that might be associated with breast cancer or, you know, something like that. In fact, the guy that I worked with was the guy who discovered the gene that was associated with breast cancer. And you would still come up with 5 or 6 genes that possibly might be associated. And so that's kind of interesting. So at any rate, so this is today what I'd like to do. And I kind of told you that I would do this, that I kind of wanted to do this because this works with confidence intervals as well as hypothesis tests. And I will post this on the on Canvas. But the question is, how do you pick the right hypothesis test? And so we're going to go over several different hypothesis tests. I just kind of gave you an example. But basically, I've got 7 questions. Yeah, 7, I was right. 7 questions that you should ask yourself. And so, so even on the homework, and I don't know, I probably won't make the homework due on Thursday because I want to go over this a little bit more in detail. But I want to give you an overview of the rest of this class, and you'll kind of realize why this class gets a little bit hard. And so the first question, and I'm going to tab this down so that we can focus on it. So I'm going to kind of come up with a similar example. You want to know if your friend is cheating while flipping a coin. You flip a coin 10 times and it comes up with 7 heads, okay? And so we'll have to decide if that is an unusual event, okay? So the first question that you should ask yourself, and this is on every question, even before you do the problem, you should ask yourself, oh, I gave away the answer though. Is this quantitative or categorical? Okay. Now, unfortunately, I gave the answer here. It's categorical because we're looking for heads or tails. Would you guys have seen that first of all to realize that the coin flip would be categorical?
Yes, because you can put them each in one.
See,
Place.
usually when I do this, most people say, oh, there's a number 10 and there's a number 7, and it must be quantitative data because I've got numbers in there. So this is actually a really hard question, okay? And I remember on the first week of class, I said categorical, quantitative, and you all said it was easy, but it's not quite as easy. So anyway, so this would be categorical. So pay attention. Just because there are numbers in there doesn't mean that it's automatically quantitative, because this is actually a categorical, because we're talking about heads or tails, okay? Now, the second question you should ask yourself is to find the null and the alternative hypothesis, okay? Now, actually, there, I'll do this. So the null hypothesis is a mathematical statement or equation that means there's no change, no difference, or that this is a fair coin, okay? So this is a definition I want you to drill into your heads. Another thing about the null hypothesis, it is always, always, always about the population. And so some common variables that you will use for this will be P, will be sigma, or will be mu, because these all represent the population, okay? So usually we will represent the null hypothesis as H sub 0. So as a reminder, once again, it's a statement of no change, no difference, or the coin is fair, okay? So now, in our case, we want to write a null hypothesis that says we have a fair coin. So how often would you expect a coin to come up heads?
%50.
It would be 50%. Okay, so I'm going to do this. So H sub 0. Okay. So which variable should I pick in this case? Should I pick P or sigma or mu for this data? And why should I pick that variable?
P,
P, why did you pick P?
because you're not flipping the coin a mean amount of times. Or
Yes, yes, that's correct, because it's a proportion, right?
yeah,
So what would you expect your P to be if this was a fair coin?
five.
Oh, you're saying 5 heads? Okay.
Yeah.
Now P would be a proportion, right? So you should, rather than picking a whole number, you should think of this as a proportion. So what proportion of heads would you expect?
Half.
Yeah, you could either say 1/2 or you could say 0.5. I would be happy with either case, either answer, okay? All right, so I'm trying not to give away my lecture yet, but yes, so in our case, your P would be 0.5. Now, let me ask you a question. What if you thought your friend was cheating? Could you come up with a different P for your null hypothesis? What do you guys think?
I just don't see a lot of ways you can cheat using heads or tails.
Well, you
So
could
I
put a
don't
piece of
understand the
could
question.
put a piece of tape on the coin, right?
So I don't, but that's like not a mathematical thing. And so I don't know what, can you repeat the question?
So the question is, could you pick something else for your null hypothesis? Because let me do it this way. I should also add one more rule here that was not on here. That it always, I know you guys like that word, always has an equal sign. Okay. So whenever you're doing your null hypothesis, it always has to have an equal sign. So even if you thought somebody was cheating, let's say you thought they put tape on there and you thought that P equaled 0.6, 0.6, that it was coming up ahead 60% of the time, you would not do that because you always say that the statement would be a no change, no difference, or in this case, it would be a fair coin. So we always assume the coin is fair, even if we think the other person is cheating. So you always say P equals 0.5. Does that make sense? You guys aren't as talkative as normal in our regular classes.
I think I'm confused about P. Like, you can't, if the probability is always going to be 1/2, I don't know how you could make it 0.6 or 0.6, yeah.
Yeah. Well, some students like to do that. I know, and this is the example that I'm giving to you. And so I'm trying to stop a question that you will have in the future, basically. So, all right. So the null hypothesis, in this case, we're going to say that our P is that we're going to assume the coin is fair, even if we think the other person is cheating. Okay. Now the alternative hypothesis. Okay. The alternative hypothesis you'll see is an H sub A, and I know that's really small. Let me see if I can make my screen a little bit bigger here. Okay. Your alternative hypothesis is either going to be H sub A or H sub 1. I don't really care. Some books use H sub A, some books use H sub 1. You'll see me, I'm going to use them both. It doesn't matter to me. And the idea is you may think that someone is cheating. And so this is where you would say, okay, I'm going to use this definition. So the alternative hypothesis in this case would depend. I keep getting a beep and I'm trying to figure out what it is. Is somebody, I wonder if somebody's in the chat saying something.
It's Waverly. She's in the lobby.
Sorry.
Oh,
You're good.
are you chatting? So the one thing is I can't really monitor the chat very well. So anyway, do you have a question or anything or?
No, I'm good.
Okay. All right. So the alternative hypothesis, in this case, we didn't really define how we're defining. If we defined it, P is the probability of heads, the alternative might be less than heads or less than, kind of depends on how you define your heads and tails. Is P heads or is P tails? Okay. So the problem's unclear. And so in this case, so your alternative hypothesis could be P is greater than 0.5. It could be P is less than 0.5. Or it could be P does not equal 0.5. Now, in real life, most alternative hypothesis tests are two-tailed. And so typically you're going to use not equal. But in the homework, you're going to have, they would better define this as, oh, you think they should get more than 50% heads, or you think it should have less than 50% heads, okay? And so, so in this case, because it's not clear, I guess if you're not sure, if the problem isn't clear what it is, we said your friend is cheating, but we don't know if that means more than 5 heads or less than 5 heads. So now you could make an argument here and say, oh, it came up 7 heads. You could make an argument that this would be a one-tailed test, p would be greater than 0.7. But honestly, you're not supposed to make that decision until by looking at the data. You're supposed to make that decision before. Now, the problem is I gave you that information there. So at any rate, p does not equal 0.5. That's going to be your alternate hypothesis. So we'll do another example in this, and I might actually give you guys a special homework assignment, I think, that's not in the book, that just kind of goes over how do you find your null and your alternative hypothesis, because I want to make sure you guys have this down, because there's going to be 7 steps that I want you to follow, and if you can't get this one right, step 2, it's going to mess up the entire rest of the problem, okay? All right, so any questions on null or alternative hypotheses at this point?
I mean, I don't understand it, but I can go back and look at it as long as you post
Okay.
this to Canvas.
Yeah,
yeah,
I will post this to Canvas. Okay. So in this case, our null hypothesis, so if we were doing this, we would say it's categorical, it's heads and tails. I would say my null hypothesis is p equals 0.5. My alternative hypothesis would be p, and it's hard for me to put the not equal sign, so I'm going to say not equal to 0.5. And this will probably be today's the homework assignment that we'll be due on Thursday. I'll probably have you do that, and I've got a special assignment that I usually assign to people on this one because I want to make sure we understand null and alternative hypothesis. But I'm going to continue on, and we're going to continue to the next step because I want to give you the next step. So the next step is step number 3, pick the correct test statistic. So basically, we're going to learn, we're going to learn a third one in here. Oh, I guess I have to update this. It could be a z-test, a t-test, or a chi-square test of independence. Now, you guys are lucky in the fact that you've only got really, well, there's actually 2 types of z-tests. So 1, 2, 3, and 4 that you have to learn. In my math 2040 class, they have 13 tests to learn, and so that becomes really difficult, okay? So the 3 tests that we're going to do are the z-test, the t-test, and the chi-square test. And then the question is, how do you decide which one to pick, okay? So you have to decide, is this a 1 sample mean, or is it a 1 sample proportion? Okay, now means a 1 sample mean would be on quantitative data, and and proportions would be on categorical data. So I should also fill in here, this is going to be a 2 sample mean, and it is quantitative. We're going to learn that one as well. Or it's also, actually, I just remembered, I guess this is an out of date file, or it could be a 1 sample mean that is quantitative. Okay. Now the difference between, so we've got 2 1 sample means. Okay. Now this one, this is how you choose between the z-test and the t-test. Do I know the population standard deviation? And if the answer is yes, then you're going to pick the z-test. And if you say no, do I know the population standard deviation? And if the answer is no, then you're going to pick a t-test. Now, if it's a proportion, you can always figure out the standard deviation yourself and so therefore it's categorical. Okay. So one thing I will say, but the chi-square test is also categorical data. Kind of the giveaway here is that it's more than one proportion. Okay. Where this is just a one proportion test. Okay. Now I have actually had some students that actually memorize. This is a 3-page document. And I guess you can do that if you want. Hopefully, I'm going to help you guys go through this, but this is going to be a very important outline. And if you want to use this outline for like your homework and things like that, you can do that, and it will help you pick. But so let me just restate here. So question number 1, is it quantitative or categorical? You're going to use that information not only for your null and your alternative hypothesis, because you have to pick the right letter if it's P or mu or sigma, but you're also going to use that information on how to pick the correct test statistic. Is it a z-test? Is it a t-test? Is it a chi-square test? Okay. Oh, and then I think I just gave this part of the lecture. All right, so how do you decide between the z-test? Most proportions are categorical, but not always. Means are real numbers. You can always figure out the standard deviation of a proportion, even if it's not stated, because that's part of the equation. So in our case, okay, we're picking a proportion, one sample, and so we're going to use the z-sample test for proportions. Now, as a reminder, you guys can use, here, I'm going to start this, just one second. In the, let me go here. In the announcements, if you go to announcements, you've got and I guess you guys can print out your own. Formulas for tests and quizzes. So just as a reminder here, you can use this formula sheet for all tests and quizzes. And so if you want to go ahead and print this out, I would prefer that you don't write on this, don't add any formulas. These are the formulas you can use. And so what gets into this is, now we're talking about hypothesis tests for means, but I also want to emphasize that all of the assumptions that I'm giving to you work for confidence intervals. So we've got all the z-scores in here. So this z-score here, let me make that a little bit bigger. Okay. So this z-score here you would use for means. Okay. This is a t-score you would use also for a mean. This is a z-score you would use for proportions. This is a t-score you will use for more than one, for 2 means. And then this is the z-score you will use for 2 proportions. I've also got the chi-square, which we won't learn for a few weeks. But all of the assumptions that you have for hypothesis tests, you will use for the same assumptions for confidence intervals. So this is going to be your confidence interval score for one mean. This is a z-score, so your sigma is known. This is going to be for a t-score, and so your sigma is not known, so you'll use a t-score. And I know we haven't talked about the t-distribution yet, and we're not going to talk about it today, but I just want you to point it out that it's coming down the pike. We've got your proportion. This is your formula for confidence intervals for one proportion. This would be 2 means to t-score, and then this would be 2 proportions. And so what makes it hard is I've given you actually all these formulas all this time, and now you have to pick which is the proper formula to use. Okay.
Rick,
All right. So go ahead.
Yeah.
those lines above x1 and x2, is that x bar on the formula sheet?
Yeah, these are X bars. Yeah, the line means X bar. So X1 bar, X2 bar.
Okay.
And that's X bar there, and that's mu. Okay. And so remember, X bar represents what again?
Sample mean.
Sample mean, and mu represents
Population mean.
population mean. P hat represents
Sample proportion.
sample proportion. P represents
Population proportion.
population proportion. Okay, so that's why it's so important to distinguish here. Now, another thing, in fact, maybe I should add this in here. I know, in fact, let's go back to step number 1. That's actually not part of step number 1. But one of the things that you may want to do as you're going through here is also to list all the numbers. Okay. So you want to know if your friend is cheating while flipping a coin. Okay, I don't have any numbers here. You flip a coin 10 times. So what is your 10? Something equals 10. What is the something?
Is that the population?
So the 10 would be the population of all coin flips in America?
Yes.
Sample.
It would be a sample, right? It would be your sample size. Okay. So your sample size what letter would we use for sample size?
X.
Nope, not X.
N?
N. N is your sample size. We always use N for your sample size. Now, you did your experiment and you came up with 7 out of 10 heads. Okay. So something equals 7. You could use X in this case. We know that this is categorical data. So am I using proportion or am I using a mean in this case?
Proportion.
Using a proportion. So the proportion, what would be the sample proportion?
7 out of 10.
Something equals 7 out of 10. Now the question is, because I'm using a proportion, is it P or is it P hat that I would use?
P hat.
P hat, because why?
It's the sample proportion.
It's a sample proportion, right? This is my experiment. You could think of this as my experiment. I got 7 out of 10 heads, so I'm going to use P hat. Okay. I wonder, should I add that on here to maybe I should make this an 8-step thing. List all the important numbers. Should I do that? What do you guys think? Should we do that? I think that's a good idea. I'm going to change my outline.
Yeah.
We're gonna make this step number 1. List all the numbers. Step number 2 will be, is it quantitative or categorical? Or would you guys rather have this be step number 2? Honestly, these two, the order doesn't really matter that much. Would you have list all the numbers be step 1, or would you rather have quantitative or categorical as step 1?
List all the numbers as step 1.
Okay. We're going to make that step number 1 then. Okay. So I'm going to update my thing before I post it up there. So list all the numbers, and then you'll have to decide, is it categorical or quantitative? All right. So this just became an 8-step process. Okay, so all right, let's just do a quick review here. Okay, so we're gonna list all the numbers. List all the numbers. Maybe I should just move this. This is going to be step number 2. Is it quantitative or categorical? I didn't mean to make that yellow. I'm going to make it green so that matches. Come on, green. Okay, so we're going to list all the numbers. Is it quantitative or categorical? Find the null and the alternative hypothesis. In our case, p is going to equal 0.5. Our alternative hypothesis is going to be p does not equal 0.5. Now we have to pick the correct statistic, which is the hard one. In this case, we're going to pick, it's a 1 sample proportion, it's categorical data, okay? So if we look back at our formula sheet, okay, the 1 sample categorical data is going to be this equation right here, okay? So we're going to use this equation, okay? So in our case, now, by the way, I should ask this question. Is our sample large enough? Let's go back to here. Is our sample large enough?
No,
No, it's not, okay? Why not?
because it's less than 30.
Okay, and I was afraid that we would say that rule. That's the wrong rule. It is definitely less than 30, but that's the wrong rule.
Is it the 10 rule? The PRQ?
The 10 rule. NPQ must be greater than or equal to 10.
In that
Looks like
circumstance, it is big enough.
No, it's not. Because what's my n in this case? My n is 10. What is p in this case?
70%.
No, p hat is 70%.
Oh. I don't know.
How often would you expect your coin to come up heads?
0.5.
Oh, 0.5.
0.5. You would expect it to come up 50% of the time, okay? So if I figure my NPQ equals 10 times 0.5, and what's Q?
0.5?
It's also
It's, yeah.
0.5, okay? So if I get my calculator out here, 10 times 0.5 times 0.5 equals 2.5. Is 2.5 larger than 10?
No.
No, okay? So this one is actually too small, okay? So we should not be doing this method. The reason I'm doing this is because I want to keep this as a very simple problem. But yes, this is too small, okay? Because 2.5 is less than 10, okay?
But
All
we
right.
can still solve it if it's too small.
You can solve it. I mean, so that's a tricky question. You can always do the wrong procedure. Yes, anybody can do the wrong procedure. Should you do it? No. I'm going to do it because I wanted to keep this as a very simple problem. And, but so in our case, we're using 1 sample Z. Technically, we're grossly violating because we're not even close to 10. We should not be using this method. Okay, but this is the one we would pick if our sample size was large enough. Okay, so I just do want to state that, yeah, we shouldn't use this. If we do use it, we're going to say, yeah, we're breaking all our rules. Okay, all right. So p hat is going to be 7 out of 10 minus p is 5 out of 10 or 0.5. divided by the square root of PQ over N. So P is 0.5, Q is 0.5, and then N is 10. So that gives me a Z score of 1.26, okay? Does that make sense so far? Anybody have any questions on that? Okay. So using the chart or the computer, you have to decide, is this a one? Is it a right tail test? Is it a left tail test? Or is it a two tail test? Okay. So the left tail test, if you had P was less than some number, you would be on the left side. If you had P was greater than some number, you would be on the right side. And in our case, we're doing a two-sided test. So we want half of our alpha on both sides, okay? And so this comes, the P does not equal some number. That comes from our alternative hypothesis. We said this is a two-sided test, okay? All right, so the idea here is, as you calculate your p-value, okay, we're going to be doing a two-sided test. So since it's a two-sided test, you need to double what the book says. Okay, so the idea here, let me back up. So I got a value of 1.26 if I round that off to 2 decimals. If I'm using the chart here, okay, okay, so I've got my normal distribution, okay? So I got a value of, this is the pits, okay? So I got a value of 1.26, so 1.2, so I'm on this row right here, and then I need to find the 0.6 column, which is this column here. Okay, so I'm looking down here, 1.26, which gives me a value of, is that right? Yeah. 1.26. Now, remember that this chart is giving me what's to the left. So I've got roughly 89% or almost 90% to the left of this line here, okay? So when I'm doing this, why did I get 0.9032? Am I doing something wrong? 1.26. That must be a different value in the computer. If I'm using the chart, I'm going to get 0.8962. Does that make sense to everybody? I must have picked out. Oh, this must be a different book. The other book must have had a different value here. For some reason, they had 0.9032 rather than there. But anyway, here, I'm going to change this. This is what we got, 0.8962, 8962. So because this value in my table tells me what's to the left of that, I need to subtract that from 1. What's that value here? 1 minus 0.8926 works out to be 0.1074. So this is 0.1074. But since we're doing a two-tailed test, I'm going to have to double it, which is going to be that number times 2, which is 0.2148. 2148, okay, which is 0.1074 times 2. Okay, now we're going to compare this p-value to our alpha. And if it's not stated in the problem, we're going to assume that alpha is 5%, okay? So since 0.2148 is greater than 0.05, is there evidence of cheating? Is there evidence the coin is not fair? What do you guys think?
Does it have to be bigger than 0.05 or less than?
That's the great question.
Okay. I don't think there's enough evidence.
Yeah, so there's not enough evidence of cheating. Okay. All right. So, oh, there we go. I already gave that. So this value here is what did I say? 2148. Okay. So you're going to compare your p-value to your alpha. Okay. And so the last step, or step 7, is that we have to decide whether to reject or to not reject. Now you've got here, we never accept, okay? We never accept that the null is true. So one way to remember this, and this is a very politically incorrect phrase, but it works. If the p-value is low, meaning lower than our alpha, then you reject the, and if you say that as ho, that rhymes. If the p-value is low, reject the ho, okay? Or the null. If the p-value is low, reject the null. It doesn't quite rhyme, but it's close, okay? So in our case, our p-value is not lower than our alpha, so we do not reject the null, okay? And then the last step is to write your conclusion in English, not statistician, okay? Because people don't want to, so the question is your friend cheating? The answer should be yes, your friend is cheating, or no, your friend, oh no, there is not enough evidence that your friend is cheating. And so as we write our conclusion, words that I don't want to hear. Oh, I didn't put that in here. Words I do not want in your conclusion. I do not want to hear the word reject. I do not want to hear the word null. I do not want to hear the word hypothesis. And I do not want to hear the word accept, especially accept. That's a terrible word, okay? So in our case, there is not enough evidence to conclude your friend was cheating.
But if there were more flips, like if there were like 100 and it kept getting like tails, then that would be enough evidence that your friend was cheating?
That's a good question. It could be. The main problem is our sample size is so doggone small. I mean, we're only flipping it 10 times. But if we flipped it 100 times, would there be evidence? We could actually calculate that, and that would be a good question. And there might be, and there might not be. We would have to calculate it to find out. But yeah, it's a good question, Caitlin, because the main reason why is because our sample size is too small. We just don't have enough evidence. Okay. So
if
here's
you
what I
had a
would
good
like
enough
to do.
sample size and your evidence, or I'm just trying to figure out how to write a conclusion if you have a big enough sample size without using those words.
So yeah, so basically in this case, the idea here is there is or is not enough evidence of whatever you're trying to prove, whatever you are trying to prove. And so here's what I would like to do. I have one more example here, and I would like to go through these 8 steps and let's see here. I think that's, yeah. Okay, so here's what I'd like to do. I want to go through these 8 steps. We've only got about 15 or 10 minutes left, but I would like to go through this fairly quickly and say, go through these 8 steps, and then hopefully you can do this. Now, my main focus on the homework, I think, is I'm just going to focus on the null and the alternative. And I'm going to ignore the equations, but we'll do this one fairly quickly just so you can kind of go through here. So step number 1 is find the numbers. Okay. You think people are speeding in a 30-mile-per-hour zone. What does 30 represent? Something's going to equal 30 miles per hour. What is the something?
Is it like an average? I mean, sorry, not average, mean?
Glad you caught yourself. Which mean?
Population mean?
Okay, a population mean, and what letter do I use for that?
Mu.
Mu. The people should be driving 30 miles per hour, okay? Local police tell you the standard deviation is 4.6 miles per hour. What is 4.6?
Sigma?
Why sigma?
Well, sigma is the standard deviation, and that's the only one I remember, so I just said that one.
Okay, so it could be S. What's the difference between sigma and S?
S is for sample.
Okay. So I'm going to leave that as a question for just a moment. Let's go on to the next thing. It's either sigma or S, okay? You find the mean speed is 35 miles per hour. What is 35 miles per hour?
Sample mean.
Sample mean, and for the sample mean we use
An X bar, maybe.
X bar, okay? You find 15 cars or 1/2 hour per, so something equals 15.
N?
Is 15 N?
And very good. And then over the 1/2 hour period, that's just kind of background information, okay? Now let's jump back to this question here. Is the sigma or S 4.6? Which letter should I use?
I personally feel
I want
like
to say
it should
sigma because if it's sigma and the police are telling you, then it's a population mean. I've seen from a lot of cars versus 15 cars, if that makes sense.
Say that one more time. I'm sorry, that other video popped up and I couldn't hear.
I was thinking that it'd be sigma because the police are telling you that it's 4.6, so it'd be more than just the 15 cars that you observe over the period of time.
Exactly correct. Exactly correct. So we're assuming that the police know what the population standard deviation is. And it is not, oh, this isn't miles per hour. It is not the 15 cars that we measured. It's not our data. Okay. All right. So this question number 2 is it quantitative or categorical?
quantitative.
Okay. Quantitative is correct. Okay. Question number 3. I'm forgetting my things here. Find the null and the alternative hypothesis. So find the null and the alternative hypothesis, okay? This is what I'm going to concentrate on for your homework tonight. So your null hypothesis is H sub 0, your alternative hypothesis H sub 1, okay? So remember, null hypothesis means it's a statement of no change, no difference, or it's a fair coin. It's almost always has an equal sign. So I'm going to put that in there. It's always about the population. Okay, so what should the null hypothesis be in this case? Somebody cut off there.
Is it 30?
Something is 30. Now I know a lot of people like to chicken out and not put the letter in there. That's only worth half credit. What's the 30?
The 30 has to be greater than x.
Okay, so up here, when we found our numbers, we had mu equals 30, right?
It's n.
Okay.
N has to be greater than or equal to 30.
So, oh, actually, since you mentioned n, let's back up a second. Is our sample large enough? What do you guys think?
I don't think it's big enough because n is 15 and that is not 30.
Right? No, because n is less than 30. Okay? Now, if I had said, and I didn't say, it is known to be normally distributed, can we get away with 15?
Yes.
Yes. If I said it is known to be right skewed, can I get away with 15?
That's a negative, Ghost Rider.
That would be a negative Ghost Rider. Very good. Okay. All right. But if I said if it was known to be normal, I could get away with 15. Okay. So I'm going to throw that
So
in there.
why did we use 30 on this one, but then on the other one we used NPQ?
That's a good question. Why?
And 30 is for population, I think. I shouldn't be answering this.
Because it's quantitative.
Because it's quantitative. So this is why I almost think you should do that question first. I mean, these questions kind of relate to each other. I don't really care whether you do find the numbers first or you say it's quantitative or categorical first, because they kind of rely on each other. But yes, so the n is greater than n is greater than 30 would be the issue here because it's quantitative data. If it was categorical data, then we would use the NPQ. Okay, so that's how those are related. All right. So mu equals 30. What's the alternative hypothesis? Now, the alternative, so actually I should also mention one other thing back here. I'm going to add some notes to my thing here. Alternative hypothesis, it's always about almost always, maybe I should change this. Almost, I'm going to change this to almost always. Because there are a few cases, there's one case where it doesn't have an equal sign. Almost always has an equal sign, often not stated in the problem. The alternative hypothesis is usually stated in the problem. On the last example, I think you were cheating, so that was what gave us the clue what was the alternative hypothesis. So let's go back down to here. You think people are speeding in a 30-mile-per-hour zone. That's a key phrase, right? Is that the null or the alternative hypothesis?
Alternative.
The alternative hypothesis, right? So we think people are going faster than 30 miles per hour. Okay. All right, step number 4, pick the equation. Okay. So as you look at your formula sheet here of all the equations, which equation should you pick? I know we need to get out of here, so I'm going to pick for you. It's going to be the Z equation, because I know my sigma. Okay. So, whoops. Say it again.
That was the first one on there.
Yeah, this equation right here. Okay. So, and in fact, I've actually got the answers here. I was trying to make you do this. Okay. It's a proper test. It's a one sample Z. We're going to use the Z equation. We're going to get a Z score of 4.209765. You can get the p-value off the chart, or you can get it using the computer. The computer value is 1.28 times e to the, or 10 to the minus 5. We don't need to double this p-value because my alternative is a one-tailed test. So in fact, this is a right-tailed test because I want greater than 30, okay? So I got a very small p-value, which means I'm going to reject the null, which means the null says basically people are not speeding, and we think that people are speeding. So we're rejecting the null hypothesis. We think that there's evidence that people are speeding, which means they're driving faster than 30 miles per hour. Does that make sense?
You lost me, but I'll just go back and watch it.
Well, this is the case. So I just want you to know there's a reason why you're all lost. I know I went through that a little bit fast. I'm giving you an overview of the next rest of the book, basically. Okay, so I'm throwing a lot of information at you. But the idea that I want to just focus on here is all of these numbers, all of these things in green, listing all the numbers. I'm going to update this so that it's good. You can review this, use it, but this. So these are the steps. List the numbers, quantitative or categorical. Find the null in the alternative hypothesis. Pick the proper test statistic. Find the p-value. Compare your p-value to your alpha. Decide whether to reject or not reject, and then write your conclusion in English, not statistician, okay? So I'm going to post this up after class. I'm also going to post a worksheet that I think I have. Let me see if I can find it here. I don't know where it is. I'll find it, but there's going to be a worksheet. It will have answers. It's what your quiz is going to be based on. I'm going to have an online quiz that's going to be due Thursday at 5 minutes before class so that you can ask me any questions about it. It'll probably be multiple choice, I think. I don't know. We'll see. So the quiz will basically be due on this outline that I've given you, as well as the homework that I'm going to post right after class. And then we will get into chapter 17. Now, the one thing that I want to mention, I really think that this outline, I know it was confusing today. It's going to get really repetitive because we're just going to repeat these 8 steps pretty much every day in class from here on. And we're going to focus mainly, chapter 17, I think I have it open, is going to focus mainly on I need to double check. But we're going to focus mainly on one time we'll do one sample means, and another chapter we'll do one sample proportions, and then we'll do two sample mean or one sample means without that. So each one of these is going to be basically a different chapter, and so it's going to, in a way, it's going to be easy because you know what's going to be the test or the equation that you're going to use, because it's always going to be the same equation for every test. So at any rate, I know this is confusing. I know we're out over time, but I'm going to let you guys go. But this outline, I think in the long run, you guys will be like, oh, this is going to make sense. Because the hardest question is how do you pick the right hypothesis test? And when I get to test, you're going to have to be able to know which of all these equations am I picking. Confidence interval formulas have the same assumptions as the hypothesis test. So anyway, I'll let you guys go, and I'll post the homework. Feel free to, you can either email me, or if you want a faster answer, text me, and I will help you guys out. So sound good?
Hey, Professor
Thank
Bennett.
you.
Thanks.
Thanks.
Okay. Thanks. I think I have a question. You can go ahead and ask the question.
Yeah, it's Corinne. I just wanted to ask you a little bit about group projects as people are leaving. Do you have time?
Oh, sure. Actually, what do you want to ask?
I was wondering if we're just on our own to figure out like meeting, or if using Teams as communication would be good, in your opinion.
Teams is good. I will tell you also, well, I think Teams, for interaction, I think Teams will be the best. There is a thing called, I did go to some trainings here. I'm in the wrong place. If you go to a college algebra class, there is a thing called conferences. Oh, right now I think it's hidden for you guys. I'll make it unhidden for you. This is the wrong class anyway. But they're really worried about, and this is the reason I didn't use it. You guys, I'll make that button visible to you guys. You guys can use conferences, but supposedly they're worried about everybody overloading the system, which is why I did not use it. But that's a possibility. I think Teams, if you want to use Teams, you should download the software, and but yeah, that's a good thing. And then you guys can meet via Teams. I think that's a really good suggestion. But I will tell you that conferences is another thing, but I didn't pick it because they told me that they were worried about people overloading the system, and this is Microsoft, and it's solid. You won't have any. I don't think you'll have any connection problems, but you will want to download the software to do that. I think that would be the best way to do it. So, good question, Corinne. Thank you.
Thank you. Yeah.
Any other questions? Okay. Well, thanks. The last thing I would just mention is all of the stuff you're learning for the rest of this class, you will use for your final project. And so this is going to be very applicable. It's also what makes the project difficult is because you have to pick the right test for your project. So, and I'm really bummed that we can't do in-person surveys. So anyway, we can talk about that next time a little bit. So feel free to ask me about that. But I'll let you guys go. Thanks again, and we'll see you all on Thursday. And don't forget to take the online quiz on Canvas before class.